Problem 2, this is a calculator-aided problem. The velocity of a particle p moving along the x-axis is given by the differentiable function, circle that there, boom, v of p, v sub p, where v sub p of t is measured in meters per hour and t is measured in hours. Selected values of v sub p of t are shown in the table above. Particle p is at the origin at time t equals 0. Very important there. Part A, whoops, I need to get on part A here. Okay, justify why there must be at least one time for t between 0.3 and 2.8, at which the derivative of v sub p, the acceleration of the particle, equals 0 meters per hour per hour. Okay, when we see something that's asking us what the derivative being equal to something, and they give us an interval, we can pretty much know that we're going to be doing something with the mean value theorem. And remember, with the mean value theorem, we would like to try to find somewhere where the average rate of change would equal the instantaneous rate of change. So I'm going to look at my chart between 0.3 and 2.8 and try to decide if my derivative, or excuse me, my average rate of change would equal 0. And I notice that at 2.8, the v sub p is 55, and at 0.3, my v sub p is equal to 55. So I know that if I find that average rate of change or the slope, I'm going to get 0. So I'm going to go ahead and just get my problem set up. So mean value theorem, we must state that the function is continuous and differentiable. So I'm going to start with, because it did say that it's differentiable, so I'm going to say, since v sub p is differentiable, it also must be continuous. Okay, so I'm getting that out of the way. And then I'm going to say, because of this and the fact that, now I'm going to go ahead and, because we need to say it's continuous differentiable, and then we have to show that that average rate of change is equal to that 0. So I'm going to say v of 2.8 minus v of 0.3 over 2.8 minus 0.3 is equal to 55 minus 55 over 2.5, which is equal to 0. So, and because of that fact, we can use the mean, we're going to spell out mean value theorem, we're not just going to put MVT theorem to justify that there, and now I'm basically just repeating this, there must be at least one time t for 0.3. Notice I'm just restating that at which v prime of t equals 0. So there we go. So a lot of it, I'm just restating what they said, but there are 3 things that I had to make sure were true. V sub p had to be differentiable, had to be continuous. Of course, obviously that just falls from that. And then we did have to find where the average rate of change would equal that 0. So this was worth 2 points. If we showed this, okay, we would get a point. And then if your conclusion mentioned the mean value theorem with the differentiable and the continuous, we would get that 2nd point. So you have to have all of the parts to get your justification point. So this would be worth 2 points. All right, part B says to use a trapezoidal sum with the 3 subintervals 0 to 0.3, 0.3 to 1.7, and 1.7 to 2.8 to approximate the value of 0 to 2. The integral of 0 to 2.8 v sub p of t. So we're going to use this interval, and we're going to use this interval, and we're going to use this interval. And since they're not equal intervals, we cannot use the actual trapezoidal sum formula. We actually have to find the areas of each of those trapezoids. And remember, that formula is 1/2 the height, sum of the bases. Okay, so the first one is going to be 1/2. The height, or the distance between there, would be 0.3. And then the sum of the bases would be 0 plus 55. And then plus, the next one would be 1/2. The height there is going to be 1.7 minus 0.3, which is going to be 1.4. Sum of the bases will be 55 plus negative 29. And then plus, that third trapezoid is going to be 1/2. The height of that would be 2.8 minus 1.7, which would be 1.1. And then the bases would be negative 29 plus 55. And then we get to let our calculator do the work, but we do definitely have to set it up to show that we're using the trapezoidal sum. And that would be 40.75. And please remember the integral was in meters per hour. And these numbers were in hours. So meters per hour times hour is meters. All right. And we would be given, guess what? Just 1 point. So a lot of times they give us the point for the setup. They just did not. This time they must not have had enough points to give. So, and I do believe if you did not have the meters, I don't think they were counting for the units this time on this one. Okay, part C, a second particle Q also moves along the x-axis so that its velocity is given by V sub Q is equal to this formula, meters per hour. Find the time interval during which the velocity of particle Q is at least 60 miles per hour, meters per hour, excuse me. And then, so this is part one. Part two, find the distance traveled by particle Q during the interval when the velocity of the particle is at least 60 meters per hour. So first of all, we need to find out when the velocity of particle Q is greater than or equal to 60. So there's a couple different ways that you could do this. The way that I did it, I graphed the velocity, which looked something like this. And then I actually graphed the line 60 because then I could tell right here, this is when my velocity would be greater than or equal to 60. So then I found these points of intersection. This left one was 1.86618, and I actually left these to 5 places because I know I'm going to have to use them in just a minute. This next one was 3.51917. So when it asks for find the time interval during which the velocity of particle Q is at least 60 meters per hour, there's a couple different ways that we could write this. We could write it like this. And we could also, if you had it accurate to 3 places, that would be fine as well. Or we could also write it in interval notation as well. And we'd get a point. We'd be fine with that. We do want to use brackets or equal signs because it did say at least, which includes 60. Okay, so that was the first part. And that would have been worth a point to get that interval. Okay, and then the second part is said to find the distance traveled by particle Q during that interval. So we know distance traveled is A to B, integral of velocity. So we definitely want to use that formula. So I'm going to be going from 1.86618 to 3.51917. And it's going to be the integral of the velocity of Q. And again, I'm not going to write out that formula. I have it in my calculator, so I don't want to accidentally write it down on my paper incorrectly. And if I do that, I'm going to get 106.109. And let's see if I want to say anything about that. Oh, nope, actually, you're going to get 1 point for the setup. And then you're going to get 1 point for the correct answer. One thing that I would like to caution you on, let's say you weren't sure how to get this interval, make up an interval so that you're able to have a setup, okay? Because as long as you are using your wrong answers correctly, you potentially will get the second point. So just try to get through, because I know that most people are going to know at least how to set up the total distance traveled. So that is worth 3 points. And I think we are through. Nope, we're not. Okay, we got a part D. Oh, do we have a part D? We have a part D, which I totally forgot to put on here. So, oh boy, we're just going to put part D up here. This could be a mess. Okay, part D, I'm just going to have to read it. It says, at time t equals 0, particle Q as at position x equals negative 90. And then using the result from part B and the function v of q from part C, approximate the distance between the particles P and Q at time t equals 2.8. So we pretty much need to know where the particles are at t equals 2.8. And if we know that, then we know how far apart they are. So for particle Q, to get the position, it's starting at negative 90. And then we would need to know how far it travels from 0 to 2.8. So we're going to find 0 to 2.8. The integral of velocity, because that's going to give us the displacement of the particle from 0 to 2.8. So if we do that, we will get 45.938. Okay, so that was particle Q. And then we have particle P. Well, particle P said it was at the origin, so that was where it started. plus we want the displacement, and the displacement, it actually said to use our answer from part B. So the answer from part B was 40.75. So the particle P's position was 40.75. So now we know where the particles are at 2.8. So now to get the distance between them, we will just do 45.938 minus 40.75, and that gives us 5.188 meters. Alrighty, and that was worth 3 points. If you showed that you are finding, we needed to find that displacement of particle Q, we would get a point. If we actually found the position of particle Q, we'd get a point. And then if we found our final answer by subtracting those two distances, we would have gotten that final point. So that one was worth 3 points. So we are now done with problem 2.